Good morning, good afternoon, and good evening. Welcome back to Chapter 18. We're still talking about mollusks. Remember, we're talking about phylum Mollusca, domain Eukarya, kingdom Animalia, phylum Mollusca. We talked about class Bivalvia, talked about class Gastropoda. Now we're going to talk about class Polyplacophora. What does poly mean? Poly means many. What's a plaque? We talked about plaque before. Plaque, what's a plaque like? Plaques are flat or plates. And what does phore mean? Phore comes from the root word phere, which means to possess. So polyplacophoran means many plate bearer. They've got 8 overlapping plates. These animals are called chitons. About 1,000 species, give or take, of chitons. Again, please don't say chitin. And notice, when we talked about fungi, we said that the protein that fungi use in their cell walls is chitin, C-H-I-T-I-N. These animals are called chitons. It's pronounced the same way, but it is T-O-N. So if you see a T-I-N, that's the protein. T-O-N is an animal. And they're not related to each other. They just happen to have similar roots. About 1,000 species of chitons. They are called sea cradles, lorikeets, or a coat of male shells. They've got 8 overlapping plates on their backs. Here we can see a chiton right here with the 8 plates on the back. If the animal moves, the plates actually kind of move back and forth. As you can see on this animal, it looks like these have been scraped clean, because as the animal moves back and forth, it kind of scrape it clean. In your mind, what does a chiton look like? Chitons are kind of like, so a snail has a shell and a slug doesn't. These are sort of kind of like intermediate between the two, almost like snails that have not quite lost their shell yet. And so these plates would kind of be like what's left of the shell. Because if you look at the underside of a chiton right here, this part of it right there, that looks just like the underside of a snail. And here's the mouth right here, and there's the opening where that radula would come out. So here's one stuck to a rock. All right, this person is holding a rock. There's the person's thumb right there. And then so here's a chiton stuck to a rock. Polyplacophorans, chitons. Our last group of mollusks are the cephalopods. What does ceph mean? Ceph means head. Pod means foot. Gastropod means stomach, foot. Cephalopod means head, foot. The cephalopods are an interesting group of animals. What is the strategy that we've been using for discussing life and now in turn animals? The strategy that we've been using has been from least complex to most complex. So we started with bacteria, and now we're talking about the least complex ones. Now we're talking about animals, the most complex ones. And when we started animals, what did we start with? We started with the simplest animals, sponges. They don't even have tissues. They only have 3 different kinds of cells. We make it all the way up to jellies, and now we've got tissues. And it's arguable whether they actually have organs. We don't actually see organs until we get up to the worms. Least complex to most complex. That's the strategy we're using. And if you want to use that, and since that is the pattern that we're using to look at the animals, what we have to do is we got to take this group, one of the simplest groups of animals, mollusks, and we have to pluck this little group, this class of about 800 species. We have to pluck this class out and put it off to the side. And if you do that, then you got a really nice transition, going from least complex animals to most complex. And it's wonderful, and it's great, it's nice and smooth. If you look at these guys are a speed bump, because they break all of that least complex to most complex idea, because they are easily the largest invertebrates. They're easily the smartest invertebrates. They're easily the most evolved invertebrates. And we've got like 3 classes of animals after, not classes, excuse me, phyla. We've got like 3 phyla of animals after this that are supposed to be way more complicated than mollusks. Still invertebrates. And cephalopods are way more complicated than they are. Easily the smartest invertebrates. And you say, well, how smart can an invertebrate be? Molluscan cephalopod intelligence. I don't want to say it's on par with dog intelligence, but it's probably pretty darn close. Some of the species are that smart. They're able to solve problems. They're able to open jars to get at treats. They're able to learn. These guys, these animals are incredibly complex and incredibly brilliant, especially when you consider the fact they don't even have a backbone. They're not even a vertebrate. They're not even part of the most advanced class, vertebrates. They're part of one of the least complex phyla, and that is mollusks. Nautiluses, squid, octopi, cuttlefish, they all possess tentacles for capturing prey. They're all carnivores. They all capture prey. Octopi have about 8 tentacles. Squid have about 10 tentacles. Nautiluses have 80 or 90 tentacles. And so with squid, there's a difference between a tentacle and an arm. The feeding tentacles are special. They have 2 of those. They have 8 arms. We're not going to split hairs. We'll just call them all tentacles. And like we said, octopi have 8 tentacles, squid have 10 tentacles, and nautiluses have 80 or 90. I got a picture of all of them coming up in just a minute. As we already said, they're all carnivorous. They're easily the smartest invertebrates. They're easily the largest invertebrates. The largest invertebrates known to man are the colossal squid. Can be 30, 40 feet long. Huge, huge, huge animals. And these guys all have closed circulatory systems. Remember, we just introduced circulatory systems in this group with the gastropods and the bivalves, and they have an open circulatory system. And these guys have a closed circulatory system. Here we see some pictures of some octopi. This is a blue ring octopus right here. They're actually highly venomous. I swore I saw a picture just this past week of like a guy holding one in his hand. That is a crazy idea. They're not very big. Hold it in your hand. That's not a baby. That's how big they get. They're literally small. Most octopi are quite small, as in like dinner plate size. Most of them are quite small. This guy is holding a giant Pacific octopus. Guess why it's called a giant? Because it's huge, and it's roughly about as long as he is. You know, 6, 8 feet long. Those are the giants. Most of them are more like 1 to 2 feet long, as in like from head to the tip of the tentacles. They're not very big. Most octopi are actually quite small. This is a nautilus, a so-called chambered nautilus. This is the shell. It really kind of looks like a squid with a snail shell on. They swim around upside down. You would think that they would do it the other way around, but no, this is how they prefer to do. Here are all those tentacles coming out of their the front of their mouth. It is very similar to a snail's shell. They are able to close it. This is the animal's eye right here. Interesting thing about cephalopod eyes, their eye is actually probably better designed than ours is. It's a really long conversation, but the short answer is the way our light detectors are inserted in our eye are backwards, and the way their light detectors are inserted in their eye is forwards. Their eye is probably actually better designed than ours is. Here we see a breakdown of everyone's favorite squid. Wait, Squidward is not a squid. Squidward is an octopus. Actually, Squidward isn't an octopus, because what does octo mean? It means 8. And how many appendages does Squidward have? 1, 2, 3, 4, 5, 6. Squidward is a hexapus. Squidward ain't a squid. What you think is the brain, let me go back to this other picture. You would imagine that the brain of the animal is in here, and it's not. The brain of the animal is located right here in the center. You can't really see here, but there's an eye of the blue ring right here, and there's another eye over there. Excuse me, this is an eye. There's an eye of the blue ring right here, another eye on the other side. And the brain, really, if you wanted to pick the animal up by the head, you'd pick it up right here. And so this big floppy head-looking thing that you think it is, that's actually their gut cavity. That's where their guts are. The brain is right in the center, right here. That's where the brain is. If you open up the umbrella of their tentacles, what we see at the center is the mouth, and they've got a mouth very similar to a parrot's beak. And the mouth, again, flop the animal this way. All right, so that big mantle cavity, the gut cavity goes back. The head is here on top with the eyes. The eyes are on either side of the brain. And then you've got the tentacles coming out like that. At the center of those tentacles, at the center of the umbrella, is the mouth. And they've got a beak, very much like a parrot's beak. This shows a giant squid. Here's a man standing over this giant squid, and you can see that the tentacles have actually been folded back. How long is this table? That table is easily 15 feet long. How long are these tentacles then that have been folded back? Those tentacles are probably another 20 feet long. So we're talking about from tip to tentacle, we're talking about an animal that's probably 50-some feet long. Very, very big, very, very large animals, cephalopods.